All right, we're going to start working on our Chapter 3 exercises, and the first one on deck here is Programming Exercise 3.1, and the goal here is to write a program that reads an integer and prints whether it is negative, 0, or positive. So this is a pretty simple one, but it does involve getting user input and involve writing an if statement to check for those conditions. So let's go ahead and do what we've been doing. We'll just copy this in. In fact, you could probably copy even the title in, now that I think about it, right? So you know which one it is right inside your code. I'm going to jump over to the Spider IDE, which is already running. I do notice that I have all these documents and programs already open here, so I'm going to close those. And then the other thing I'm going to do is I'm going to grab my file folder, and I'm going to bring that over to the screen here. And I've been putting all my code in here. So what I'm going to do right now is I'm actually going to create a new folder for Chapter 3. And I suggest you do that preemptively. And that way you have a place to put your files right away. All right, move that back off to the other side. Screen number 2. And let's go ahead and save this one. This is going to be Exercise 3.1. And I think that we've been kind of naming them like this. And I'm going to give it a name too. Neg, pos, or 0, just so I know what it does. And maybe I should make the O here cap. It should have a PY extension to it, and then we should put it in the right place. I'm going to find that folder here in my file structure. There's my Chapter 3, and I'm going to do a save. All right. I'm going to go ahead and paste the program description in here. And remember, that's not obligatory. I'm just doing it to make my life easier, so I don't have to flip back and forth. All right, the first thing that we want to do is we want to get input from the user, right? I'm just going to type a little comment here, get input from user in the form of a number, right? So when you prompt the user, how would you do this, folks? We need to set up a variable to hold it, right? Mm-hmm. Could I suggest that we just call it num? That's a real common one in programming. And then we know we want it to probably be a counting number. Can we all agree to that? Did it tell us? Oh yeah, it reads an integer. So we know we're going to convert to an int right away. So I'm just going to put that in there with parens. And then inside the parens, we're going to put the input with another set of parentheses with a message we're going to use to prompt the user, which I think might be a good idea to just say enter an integer. Now programmers always remember what integers are because we have to think about that, but unless you're like actively taking a math class, that's one thing that you often forget. So like if you were doing this for like a common user, you might throw in the thing that says an integer is a counting number such as 1, 2, 3, All right, so we got the input from the user. The next thing that we want to do is analyze the number. So I'm just going to make a little note here. Analyze the number and display results. We're going to kind of do that all in one fell swoop. So we're going to begin by writing an if statement. And what are the 3 scenarios? We got to check to see if it's negative, 0, or positive. What makes the most sense to me to start with is positive. Right? Because I anticipate that most people are going to put in a positive number. That's just my guess. But I'm going to say if num is greater than 0, we put in the colon. That's our way of saying then in Python. And notice what I just did. I pressed enter, and what did Python do for me? Yeah. Isn't that wonderful? It just it indents automatically, and you know what you do is you go with it, right? and it looks like it's a tab. All right, so now it's waiting for a result. So if it does happen to be greater than 0, we know that what? The number is positive. Okay. Now, notice what it did. I pressed enter, and it kind of thinks I'm going to type another statement here, but really, I'm kind of done already with this series of statements, and I really want to do an else if, right? Would you guys agree that that's the logical choice?
Mm-hmm.
Why?
Because it's multiple choices.
Yeah. It can't be negative, positive, and 0. It's going to be either ors, basically. All right, so my cursor, if you saw that, was right underneath the P in print, and I hit backspace to put it back to the margin, because if I'm going to do an else if, or an elif in this language, I can check next to see if it's 0. Right? And if it is 0, then we'll print number 0, I guess. Right. Once again, I put my cursor right underneath the P. I don't have any additional statements to make. If I did, I could. So I'm backspacing again to go to the margin. And then I'm typing in else, because this will catch the other scenario. I don't actually have to check the last scenario, because if it's not greater than 0 and it's not 0, it must be negative. See the logic, folks? Now, if you did check to see if it's less than 0, no problem. It'll still work just fine. So I wouldn't downgrade you for that, but it's not necessary is my point. All right. Is there any other work we need to do here? Yeah, I don't think so. You know, I might argue that I should make these all complete sentences, and that's really about it. All right, so I'm going to do a Control S to save. Let's go ahead and run this, make sure it works. I'm going to enter an integer. Do you guys see what I did? I typed in letters. Right. Well, that's what we were just talking about a little while ago. So I'm running it again, but your users might do that. Okay, so later on we learn that exception handling, we'll learn how to deal with it. But we could also write that little tidbit in there to exit the program if it doesn't fit instead, so you wouldn't get all this stuff on the screen. All right. So I'm gonna be nice this time and actually enter an integer. So I'm gonna type in 5, and it says the number is positive. You know what? I don't trust that it works in all scenarios. I better test all scenarios. 0. Run it again. -3. All the scenarios work, right? We tested all of them. I think we're good. All right? So if you've written it, save it, screenshot it, drop it into your document. Let's move on to the next one. All right, that completes the first exercise. Let's move on to the next one. You know, I should probably check Blackboard. I don't have them all memorized yet. We're going to do exercise 3.3 next. So I'm going to go back over to my browser here to find my book. All right, and exercise 3.3 is this one. I'm just going to move it over to the IDE. We're going to go ahead and create a new file. First thing we do is save as, and this is exercise 3.3. What are we doing in this? So I'm going to call it how many digits .py. All right, once again, I'm going to paste the instructions up here at the top just to have them handy. So it says, write a program that reads an integer and prints how many digits the number has by checking whether the number is greater than 10, greater than 100, and so on. Assume that all integers are less than 10 billion If the number is negative, first multiply it by -1. So we're allowing for negative number input, see? Just in case we get those sneaky types that try to throw us off. All right, let's get started. Well, we know we're going to have to get input from the user, right? It's going to be in the form of an integer again, right? Could we just copy this statement right here? Yeah, why not? Why type if you don't have to? So we're going to get the same input here. All right. The next thing that we want to do, my opinion, is if they happen to put in a negative number, let's take care of that right away and cross that off the list. So I'm going to do this. I'm going to put in a comment. It says make a negative number positive if using an if statement. So, or using an if statement. So here's how we're going to do that. We're going to check to see if the number is less than 0. And then if it is, then we're going to set the number equal to the number times -1. That will eliminate the negative. A negative times a negative is a positive. Now we start figuring out the number of digits. So this is actually going to be kind of like a lengthy list of multiple decision statements, because I want you to think about this. We're going to check to see if a number is less than 10. And if it's less than 10, how many digits does it have? 1. If it's less than 100, it's got 2. Right? So you see the pattern? So we're just going to kind of do that over and over again. So I'm going to get us started, and they said 10 billion is our limit.
That's 10 zeros plus the 1, right?
Well, it's, yeah, 10 zeros and the 1. That's correct.
So that's going to be our max.
That's going to be our max.
Okay.
So here's where we're going to start. We're going to start with a simple if statement. And we're going to say if num is less than 10, then digits, so this is a new variable we're creating on the fly here, is equal to 1. I pressed enter and then I'm backspacing. Then we're going to do elif, if I can type it right, num is less than 100, digits will be equal to 2. Backspace. And this pattern is just going to continue. So the pattern is we just keep adding a 0 to this statement, and we'll keep adding 1 to this. So if you want to follow through the whole pattern, frankly folks, I'm cheating. I'm going to type them all in at once, because I can. So it should look something like this when you're done. It's like, gee, teacher, that's not fair.
But we're really just incrementing the digits by 1 every time you check the higher from 100 to 1,000,
Right.
1,000 to 100,000 to a million.
That's absolutely correct. So every time we're adding another number to another 0 to the number, we're adding another place of digits. Now I copy pasted in from a different program, and I'm noticing that this program doesn't do the same tab depth, and I'm wondering what will happen here as a result. And you know what? I'm going to wait. It's not like flagging it as a mistake. It's still reading it in as a tab. So I copied it in from a different text editor, so that should be kind of interesting. Finally, when your work is done, you do need to put the result up on the screen. And you might want to do something that looks like this. So notice what I did is the number had so many digits. I might even be a little persnickety here and put in a line feed just to make it look a little cleaner, but that's me. I don't think that's ever a bad idea to have nice looking output. So I'm going to pause the video here while you guys busily type this. All right. So make sure you test it with lots of different approaches. Now I tried a few here and I forgot to hit record, so I'm just kind of now recording it. So I ran the program, put in a 3, I put in a 55, I put in 3 6s, I put in whatever this is, and really hypothetically you should test all the scenarios. The one thing that you could do is try to exceed this number. Yeah, and see what happens. Can I paste it in? I sure can. Mine counted 8. That's interesting. Well, yeah, I suppose it would be if it's less than. Okay, let's try that again. So it's 1, 1. Just trying to count all the digits here. 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 digits, and I'm going to exceed it by 1. That's 11 digits. Huh. That's really interesting. That's not what I would anticipate as the output. Now, I know what's going on here. Does anybody know what's going on? So if you get to the last 2, Ethan, what's your guess? No, that's a good guess, though. It's a good guess. Ethan's guess was that because we don't have a default. Actually, what's happening is we're running into the number limitation capability of what an integer can hold as a variable. Once we get past those 8 digits, and I'm surprised the author doesn't have a little side note on it. Once we get past those 8 digits, we really should be using exponential notation. That's really what's happening. So that's kind of an interesting little lesson there, isn't it? What I think is fascinating is that it wouldn't still read it back, but it shows you that an integer really can't hold it. So a very fascinating little example. And there's nothing wrong with your code, but that's how you would do the logic of it. All right, is everybody okay? Can I move on? Okay. All right. Our next exercise, let's see if we can find it here, is going to be exercise 312. So that's going to have us scroll down a little bit here. Oh, this one's a little more fun, because this involves something slightly more complicated. All right, so this one, let's go ahead and let's start a new program here before we move on. And let's do a save as immediately. This is exercise 312, and I think this is like letter grades, so I'm just going to call it that. And then I'm going to paste the description in here at the top, and I'm going to read through it. It says, write a program that translates a letter grade into a number grade. Letter grades are A, B, C, D, and F, possibly followed by plus or minus. Their numeric values are 4, 3, 2, 1, and 0, respectively. If there is, so there's no F plus or F minus, and F's an F. A plus increases a plus, so not A plus. the plus sign, this would be a better way to say it, increases the numeric value by 0.3, and a minus decreases it by 0.3. However, an A plus has a value of 4.0. You can't go above 4.0, folks. So A pluses are irrelevant, if teacher ever gives you one. And a letter grade of B minus, for example, is 2.7. So this is, how they determine your GPA. I don't know if you guys are aware of that, but that's how they calculate it. All right, let's figure out how to do this. So the first thing we need to do is we need to get the letter grade from the user, right? That's just going to be a string, right? Because if they type in A plus or B minus or C, whatever, that's just going to be text. So we can just do that like this. Oops. So I'm going to write an input statement. All right? And I'm calling it letter, by the way. So enter a letter grade. And the funny thing is I have to do grades for you guys on Friday for midterm, right? And this is exactly what I have to do, is I have to calculate your scores, look in percentages, and then I convert it to a letter grade. That's what I do. This goes the other way, though, because once you have the letter grade, then this determines your GPA is really what it does. Right, the next thing that we need to do is we need to convert the letter part of it that they type in to the actual point value. So this is a little trickier. Now, if you remember, whenever we're dealing with a string, and I'm going to create a new document here, and so somebody might type in, and this is just a scratch pad, somebody might type in, enter a letter grade, and they might type in, A minus, for example. Our job is to read just the letter part right now. To do that, we would basically do something like this. We would type letter in position 0, because that's the starting position of the string. That's the only part we want. So that's how we're going to indicate it. In fact, since I already typed it, I'm going to copy that and bring it back over to our program. So now we're going to do an if statement. We're going to say if letter in position 0 equals, let's start with an A, let's be optimistic, right? A. And now, I'm thinking, I'm asking for capital letters here too. I might actually say in capital letters, please. You idiots. No, I mean. That's right. We want to cover that scenario. I mean, if you wanted, I could set it up actually, and I know some students are going to do this. They're going to go through the trouble of going, if letter 0 equals A or letter 0 equals lowercase a, that would be the one way to cover it. Funny thing is when I use the grading system here at school, it forces capital letters too. So it's kind of a convention, right? All right. So if that happens, then we're going to set the number value to 4. But not just 4.0, because we want num to be a floating point number because we might be adding stuff to it, right? Press enter, then I hit backspace. Now I'm going to do an elif. And now we're going to say letter 0 if it equals B. What's the value? Well, then if it's a B, it's a 3.
Oh, it's a 3.
And then, you know what? I see no reason to keep typing myself. Now I'm just going to change it to C and to D. And guess what? If you don't hit any of those, guess what they have? Sorry, in that case, you got an F, which is equal to 0. And that's what you don't want on your transcripts, folks. So if you're ever like in a situation in a class where it's not going well and you don't think you're going to pass, you might be better off withdrawing from the class because a W on your transcript doesn't give you that 0 and doesn't affect your GPA. You guys hearing me? This is word to the wise. Okay, so if it's not A, B, C, or D, then it is an F, and then you get 0 grade points. We also have to fix all these, right? This is a 2, and this is a 1. Okay, so we got those scenarios all typed in, and now I'm going to type the next part in. Now we have to deal with the plus or the minus. Okay, so I'm just going to put a little note in. So we're going to handle the plus or the minus if it is present. All right, so first thing we're going to do is we're going to check and see if the length of the letter that was typed in is greater than 1, because otherwise there's no reason to check for it. So let me show you how I would do that. I would type if len, this is the length function of letter, is greater than 1, okay, another stipulation, and the other stipulation is if it's F, it's irrelevant if it's plus or minus, so I got to cover that scenario, and the letter in position 0 does not equal F, and I have to make sure I put quotes around that. Then we can go ahead and do the plus or minus. So there's a couple little tricks here, right? And this is stuff that you might not be able to logic through initially as a programmer, but be patient with the logic part because that will come. Usually it's just a matter of practice. The next thing I'm going to check to see if the length of the letter is greater than 1 and it's not an F that the person is getting, then I can go ahead and check the letter in position 2, which has got an index value of 1. And if that is equivalent to either a plus sign, and the other scenario is that it's also not an A, right? Because if you have an A that's got a plus on it, it doesn't even count. You guys catching that? That logic might be daft for you a little bit, and frankly, I would expect most students to miss this piece of it. But this is the correct way to do it, because it covers all the scenarios. Then we're going to add that 0.3. So we're going to say num equals num plus 0.3. We're going to hit backspace once because we're going to have an else if here. The else if, of course, is if the letter in position 1, which is the second position, remember that, first position is 0, is a minus sign, then we're going to do the same thing we did here, but we're going to subtract instead. And then all that's left to do, folks, is to put it up on the screen, believe it or not. And I'm going to do that like this. That's the whole program. Now, the trick in this program is two things. The first thing is reading the first letter, right? And then from reading the first letter, setting the base value of the grade point. Then it's a matter of checking a couple of things. We're checking to see if it's more than one character. If it's 2 characters, they put a plus or minus in there. We're checking for that scenario. And then we're also checking to make sure that it's not an F. Because if it's an F, the plus and minus is irrelevant. See that? Yeah, that's why we're doing that. So both of those scenarios have to catch. But we're only checking to see if it's... So summarily what we're doing is we don't want to be adding 0.3 to an F. That's the point. And that's how we're doing it. As long as the position in letter 0 is not an F and the length is greater than 1, Then we're going to go ahead and add the 0.3 as long as the letter is not an A, because to A we can't add the 0.3. So I will tell you that there's more complicated ways to write this statement. This is the most efficient way, at least that I can think of. All right, I'm going to go ahead and do a test run of this. Oh, I must have an untitled program here somewhere. Oh, this one here. I'm going to close that one. All right, now I'm going to go ahead and run this one. Okay, I'm going to put in a B plus. So what should be the result?
B plus, I'm guessing, not great at math,
3.3 should be the result. Yeah. This is kind of an interesting scale, though, when you think about that relative to your grades and what your grades mean. All right, I'll leave that up on the screen for a moment as you guys busily copy my code. Okay, our next exercise is going to be exercise 314, and this is going to be kind of a fun one, I think, right? So I'm going to copy all that and bring it over to Spider. I'm going to create a new file, save as immediately, and this is exercise 314, cards. I'm just going to call it cards if that's all right. .py. I'm going to paste the program description up at the top here as I've been doing. All right, and it says, write a program that takes user input describing a playing card in the following shorthand notation. So an A is for ace, 2 through 10 for the numbered cards, J for jack, Q for queen, K for king, D for diamonds, H for hearts, S for spades, C for clubs. Your program should print the full description of the card. For example, if you entered the card notation QS, it should output queen of spades. Okay? So one thing that we know is we're going to read the input, allow it to basically find which is the correct scenario, put the full text of the word out there. We're going to insert the word of into the middle of it, and then we're going to add the suit at the end. So of is going to always be part of it. So 2 of hearts, ace of spades, etc. All right. So let's get busy on doing this one. This one is more busy work than anything else in my mind. Doesn't mean it's not fun. So first thing we'll do is we'll read in the input from the user. This will come in as a string again. So there's no reason to do anything aside from something really simple like this. So I'm just doing I'm calling it card, enter the card notation. And we're assuming that the user gets it, right? Right, because I don't want to have to write a paragraph. Although if you wanted to be really polite, you could give them this whole description here. But we're not going to do that to them. All right. The next thing that we're going to do is we're going to determine the value of the card. So what that means is we're going to try to figure out the first digit is the value of the card. You catching my drift here? So whether it's a numbered card, a queen, a king, a jack, or an ace, the first part is the value of the card. The second part is the suit of the card. So I'm going to create another variable here, and I'm going to say value equals card, whatever's in position 0. Because that's going to tell me the value of the card. The 2 through 10, ace, jack, king, queen. Okay. Now, this is kind of weird, but really what I'm trying to determine here is because think about this, if the card is 2 through 10, 2 through 9 would be the value of the card. Unless it's a 10, right, it would just be a 1. Yeah, so we got to set up this like weird little scenario, and this is the kind of things that programmers think about, you guys, right? If the first digit is 1, the only possible value for that card is actually a 10. Catch my drift? And I can tell that just by the first digit, because there's no other card that would fit in that scenario, right? Otherwise, what's going to go in there is going to be Queen, Jack, or J, Q, K, or A, or a number. The only one that's an oddity is the 10. So if somebody types in 10, we're going to read the first digit, which is a 1. We're going to change it to a 10, so we can say 10 of spades. Okay, that's the intent here. All right. Next thing that we want to do is we want to determine what the suit of the card is. And, oh boy, how are we going to do that? Well, if we're going to determine the suit of the card, then we have to look at the length of what was typed in. And we need to look at what is the length of whatever they're going to type in?
0.
That's 2 or 3. Yeah, that's the right thinking. It's going to be either it's going to be 2 characters long or 3 characters long. Yeah. Yeah, we don't have a lot of time left. So in order to determine the suit, I have to find the card in position, whatever the last position is, right? But I don't know in advance if it's 2 digits long or 3 digits long, so that creates a little bit of a problem. So normally what I would say is I would do this. I would say the suit equals the card in position 1. And I put in curlies, but I meant to do square brackets. So whatever's in position 1, so if they type like 2 of 2H, it's 2 of hearts, position 1 would be the H, and I would know. But if they type in a 10, it kind of blows it. So really what I have to do is find a more eloquent way to say that last position. And this is how you do it. So instead of putting in a number, I actually look at the length of the card first. So if I type in 2 characters, it's going to say 2, and then I subtract 1 and I'm in the right spot. If they type in 3, it subtracts 1 and it puts me in the second spot. See the trickery there? And it's not really trickery, it's just logic, folks. So the length of the card minus 1. And that will give me the right, that will set up the suit. All right? After that, then we have to actually do the if statement that determines the other stuff. So the other stuff would be getting the full name of the card based on what they typed in. So I'm going to start with like the royal card. So I'm going to say if the value equals a capital J, then full name is assigned to Jack. All right? And you guys can extrapolate from there, right? In fact, if you start doing that, you're going to come up with a scenario that should look hopefully like this. So if it's a J, it'll be a Jack, else if it's a Q, it'll be Queen, else if it's a K, it'll be King, else if it's an A, it'll be an Ace, else it'll be the value that we already set up above, which is going to be 2 through 10. See the logic here? All right. Now we need to start building the string, and we already have a variable created, and what my thinking is we need to find a way to add of to it. So we already have Jack, Queen, King, Ace, or 2 through 10 stored in full name, or excuse me, stored in value, and we need to kind of append that of to it. So here's how I'm going to do it. I'm going to drop in some code that looks like this. Right? So full name will be whatever name we pulled, or the value, right? So 2 through 10, or one of these names. Add the word of to it with spaces around it. Next, we need to put in the name of the suit, and so we're going to need another series of if statements here to do that. So now we're going to be looking at the suit that we figured out up here, and then we're going to convert that to something else. So here's how we're going to do that. And I'm going to put in a little comment here. I'll start by going, if the suit is equivalent to S, then full name equals full name, so we're going to just add on to name basically, or concatenate if you will, spades. Else if suit equals H, then, and you guys hopefully will see the pattern now, hearts. And now that we have an else if typed in, we just need to change, and we C for clubs, D for diamonds. And then finally, we have our statement all built now, covering all the scenarios. We just have to put it on screen, and all we have to do is actually print out the full name, and that should do it. Control S to save. I'm going to go ahead and run this, folks, since our time is waning quickly. So I'm going to type in A-S. What's that? Should be ace of spades. Let's run it again. Let's see if we can put in 4D, 4 of diamonds. It seems to be working, right? Hypothetically, you should really test all the scenarios. I can understand if you might not on this one. How many scenarios are there? 52, right? But don't forget the joker. Right? One we should probably try is 10 of C, right? To see if 10 of clubs, that works too. And hopefully you guys are successful in creating this one. I will once again pause the video here for you, all of those copying code right now. I'm now going to move on to exercise 15. And exercise 15 is this one here, so let's copy that and bring it into Spider. And go ahead and make a new file. Immediate save as. I hope you guys are catching that pattern. You should follow that pattern always. And I forget what this one's about. Reads in 3 floating point numbers and prints the largest without using the max function. So really what they want you to do is use if statements, not the max function. So that's kind of the trick to that one. And this is a classic programming problem, folks. Chances are that you'll have a exercise like this in just about any language that you'll learn. So I'm just going to call it largest number dot pi. All right. So first thing that we have to do is prompt the user for three numbers, right? Because it says it reads in three numbers. So I'm going to do it like this. I'm going to do three prompts to the user. And notice I'm allowing for floating point numbers here. You could make it for integers too, that's fine. But they are giving examples with decimal places, so that's why I chose float. And then we need to write the logic to do the work. Now I do have this pre-written, so because we're kind of on a tight timeline here, I'm just going to paste it in so you can see the code, and then ultimately we will display the values when we're all done, like so. But let's talk about the logic a little bit. So a person's going to put in three numbers and they get saved into variables. And then at some point you have to come up with some algorithm for checking, okay? So the first statement says, if the first number is greater than or equal to the second number, and the first number is greater than or equal to the third number, the largest number must be the first number, right? Otherwise, if the second number is greater than the first number, and the second number is greater than the third number, then the second number must be the largest number. See the logic? Otherwise, I don't have to test anything else. The third number is bigger. Just as simple as that. So this is kind of one of these logic things. And if you approach this the first time, you might struggle with this a little bit. Like, what's the logic? It's like, this is why they create a function called max, because we're only doing three numbers. What if it's 1,000 numbers? You have to write a statement that covers all the scenarios.
If you keep adding more L's, they keep adding more on the lines, right?
Yes, exactly. Yeah, so if you had 1,000 numbers going in, those if statements would have like 999 ands or whatever to make it all work. So not very efficient. And actually what will happen is when you get past a certain point, and I'm going to say when you get past like maybe 5 or 6 or 10 of these statements, what really you're going to discover that there's other algorithms that actually work better, that actually comprise the max function. But that's a whole separate field of study. If you guys ever formally studied computer science, you would learn stuff like that. So that's how you complete this particular exercise. For those of you interested in exercise 319, I think I'm just going to go ahead and record that one in right away too. And once again, class is done, so you guys are not obliged to stay, but if you stay, that's wonderful. So I'm going to move on to that exercise, and 319, let's read that one, or copy that in. So 319, this one says, write a program that prompts the user to provide a single character from the alphabet, print vowel or consonant, depending on the user input. If the input is not a letter between A and Z or A and Z, or is a string length of greater than 1, print an error message. Okay, so that's a few different scenarios that we're covering here. Let's go ahead and once again start a new program. Save it. This is exercise 319, and I'm going to call it letter checker. Sounds like a good name to me. .py. Put in the problem description so we have it handy. And let's start by getting input from the user. So we're asking them only for one single character. And I'm going to tell you what, once I get the character, I can do all the stuff that was asked by converting it to uppercase. And I think it's, you know, or I could do it lowercase, but I'm just choosing uppercase, because that way we're on a level playing field. There's less stuff to check that way. That way if I'm checking for a vowel, I don't have to check A or E or E. See my thinking? I can just check one. It makes the program a little bit more efficient. And then I'm going to just do a series of if statements, and here's where I'm going to start. I'm going to start with a simple if statement that's going to check to see what the length is, you know. So this is going to check to see if the length is equal to 0 or the length is greater than 1. That didn't have a valid length. So if they didn't type anything in, it would be 0. They might have just pressed the enter key. Or if it's greater than 1, I know it's not a single character, so I'm just going to give them a message that says, hey, that's not right. Not a valid length. One single character. So if it passes that test, then I'm going to check to see if it's a vowel. And what you might initially think that you should do is to go if CH equal A, if CH, etc., etc. And really, you can actually do it in the shortcut way. You can do it like this. You can say if CH is in this string, A, E, I, O, U, sometimes Y, right? It's a vowel. Isn't that nice? That's one of those cool little features there. So if that letter is just part of this string, that works. The next thing that we can do is we can check to see if it's a consonant, and you got to think about it like this. If it's A, E, I, or U, it already got caught here, and they're out of the if statement. If it's not, then I can do a separate piece of logic, and oops, that's not the logic. This is the logic. If it's greater than or equal to A and less than or equal to Z, we can do that because there are numeric values that sit behind them. It has to be a consonant, because if it was a vowel, it would have caught here. Isn't that an interesting approach? So then we know it's in that, you know, possibly in that range. And then if they type something else, like a, you know, question mark or something like that, that's a single character, but it's not a letter, right? Then we would have to have a catch-all that would say that it's neither a vowel nor a consonant. It's really pretty simple logic. Believe it or not, that's the whole program. Because we're doing the output statements right away too. We should give it a shot. Let's run it. So let's put in, I'm going to put in a lowercase letter just to prove the point. Okay. Let's throw in a vowel. Oops, not there. Here. Let's throw in something that's neither, like exclamation mark. So here, I mean, with very little code, this is a really handy little routine here that you could add to any program where you're asking for a person for letter input, single character, just to make sure it's valid. Not that you would put these messages on the screen, but at least you could, you know, find ways to exclude or include certain things. So I think this is, you know, our aspects of this are very handy. All right, folks, that completes our regular exercises. There are also 2 extra credit exercises for which I won't post solutions because they're extra credit. You want to earn it, you gotta earn it if you want to earn it. So, all right, this video ends here. See you next week.